Okay, welcome friends. Today we are going to discuss about I/O ports of PIC microcontroller. These are the peripheral functions associated with the microcontroller. I/O ports is a very important part of microcontroller. Here we have 5 built-in ports, 5 numbers of built-in I/O ports. 16F, 6X, 7X family microcontrollers possesses 5 I/O ports in their chip. So these I/O ports are very essential for communicating with the peripherals. As you know, peripherals are the surrounding devices. Devices surrounded by the microcontroller, they can be called as peripherals. These peripherals are communicating with the microcontroller by means of these I/O ports. These ports are parallel ports. There are 2 kinds of ports, serial port and parallel port. What we are going to discuss now is parallel port. So there are 5 kinds of I/O ports inside the microcontroller. Now we are going to see. Okay. See the list of microcontroller ICs. The first column denotes chip numbers. There are various versions of the 16F or 16C series. 16C and 16F are more or less same. There are various versions: 62A, 63, 64A, 65A, 72, 73A, 74. So various versions of the 6X, 7X family are listed here. And the next column shows the total number of pins in each chip. 62A, for example, 62A consists of 28 pins. 63 consists of 28 pins, whereas 64A consists of 40 or 44 pins. Depends on the package. Depends on the package. Either 40 or 44 pins will be there. So the total number of pins is more in 64A. In 65A also 40 or 44 pins are available. In 72 and 73A, 28 pins are available. 74A, 40 or 44 pins are available. These are the total pin count in each version of the chip. So out of these total pins, how many pins are allotted for I/O operations? How many pins are allotted for input-output port operations? Here, 22 pins. 22 pins are out of 28 pins. 22 pins are allotted for 62A and 63A devices. In 64A and 65A devices, 33 pins are allotted out of 40 pins. Once again, in 72 and 73A, 22 pins are allotted for I/O operations. So more number of pins means, if more number of pins are allotted for a I/O operation, what does it mean? Now more number of devices may be connected. More number of devices may be connected. So in 74A, 33 I/O pins are available. That means 33 different peripheral devices may be connected. 33 lines from various peripherals may be connected in 74A. So that is the meaning of I/O, number of I/O pins. Then in EEPROM, what is erasable, programmable, read-only memory. This is called EEPROM. So the chip's memory section. Chip's memory section. Here we are having 2K memory and 4K memory in 62A and 63. Whereas in 64A, we are having 2K memory, 2K EEPROM. As you know, EEPROM, you can program it. Read erasable, programmable, read-only memory. Any program can be burned into the EEPROM. Any user-designed program can be burned into the EEPROM. So 4K space is available in 73A and 74A types of devices. And RAM bytes. RAM means general purpose registers. Register file is called RAM. Register file is called RAM. 128 bytes. Here 128 bytes. Here 63 provides 192 bytes. 64A allows 128 bytes. Likewise, a number goes. And now this is about and EEPROM and RAM size. EEPROM and RAM size. And ADC, analog to digital converters. No analog to digital converters in the first 4 versions. 62A, 63, 64A, 65. Analog to digital pins are not available. Analog to digital pins are not available. Whereas in 7X versions, in 6X versions, no ADC is provided. In 7X version, 5 channels of ADC are provided in 72 and 73A. In 74A, 8 channel ADC is available. 8 channel ADC is available. Next, coming to the USART, Universal Synchronous Asynchronous Receiver Transmitter, shortly called as USART. So no USRT in 62A, whereas 63 consists of USART facility. USART means serial communication can be established with the help of USART facility. USART means Universal Synchronous Asynchronous Receiver Transmitter. If you have this section in your chip, then you can communicate serially with the peripherals. That is the importance. So in 72 and 62A, there is no USART provision. In other chips, USART is provided. Okay, like that's the several peripheral functions. Now we are going to concentrate on I/O ports. I/O ports. So there are variety of variations. Earlier I said there are 5 ports in PIC microcontroller. Port A, port B, port C, port D, port E. 5 ports are provided. 5 I/O ports are provided. Port A consists of 6 bits. That means 6 lines. Port B consists of 8 lines. So this column shows the 64A, 65A, 74A chip. This column provides data for 62A, 63, 72, 73A. So almost the same, only here only difference. Here only difference. Okay. Port A consists of 6 lines in both types of chips. Port B consists of 8 pins. There will be 8 lines in port B. In port C, similarly 8 lines. In port D, 8 lines in this kind of chips, and no port D in these versions. Port E, similarly port E. Port E, only there are 3 pins available here in these chips, but no pins are available, no IO pins. There is no port E and port D in this group of devices. Okay. So summing all these numbers, you will get a total. So there are totally there are 33 pins. There are 33 pins. IO pins number is 33 pins in 64A, 65, and 74A chips. But in this group, only 22 pins are available. So total pin count is also given here. So in this group of devices, there are totally 40 pins. Here only 28 pins. So in 28 pin chips, there is no port D and port E. Whereas in 40 pin package, 5 ports are available. Next, you look at the second column. Look at the second column. What is the meaning of second column? Alternative use. The same pins of same 6 pins of the port A, they are also used for ADC functionality, ADC functioning, analog to digital function. It is only available in 7X series. So dual functions. These 6 pins are multiplexed. That means they are used for port A function as well as ADC function. So these are multiplexed pins. The 6 pins are multiplexed pins. These 6 pins are multiplexed pins in 7X. Whereas in 6X series, exclusively these 6 lines are used for port A. That is the meaning. So alternative use for port B. So in port B, there are 8 lines. These 8 lines are also used for external interrupt handling as well as port B. So 2 uses for the same 8 lines. That means lines are multiplexed. They are used for dual purpose. For some time, it is used for external interrupt handling. In other times, it is used for port B function. Similarly, for port C is also multiplexed. So port C has 8 lines. These 8 lines are common for serial, timer, and IO functions as well as port C. So multi-functions are provided for these pins. Each pin acting as a multiple functions. Next, port D. Port D also serves as a parallel slave port. This is called a PSP, parallel slave port, which is used to communicate with the other microcontrollers. One microcontroller can be connected with another microcontroller, or one microprocessor can be connected with one microcontroller using this PSP port. PSP means parallel slave port. So these 8 pins of port D can be used either as a parallel slave port or as a port D lines. So 2 functions allotted for these lines. It is called multiplexing. It is called time multiplexing. Next, port E bits. The 3 bits are available. These 3 bits are used for analog to digital conversion in 7X also. 7X series. But these pins are also used for port E. Sometimes it is used for port E. Sometimes it is used for ADC. It is called multiplexing. So as a whole, port A 6 pins, port B 8 pins, port C 8 pins, port D 8 pins, and port E 3 pins. totally there are 33 pins in 40 pin packages. Look at the pinout of the PIC microcontroller 7X series. 40 pin package. So look at the 40 pin package. So pin 1, master clear slash VPP. Programming voltage. VPP means programming voltage. When you are going to program the chip, you have to give some voltage here. The same line, pin number 1, is also used for master clear. Master clear means it is similar to reset. All the internal registers are cleared, are brought to the beginning state. This is called a master clear. Not only this microcontroller, anything which is connected with the microcontroller is also cleared. This is called a master clear. MCLR bar. This is the active low pin. When you give 0 signal, that means low level signal here. Logic 0 here. Master clear will be activated. When master clear is activated, microcontroller becomes cleared. Then second pin is shared. Second pin is shared for port A as well as ADC port. As I already said in the previous table, 7X microcontrollers, for 7X microcontrollers, port A and ADC are multiplexing. So AN0 means analog channel 0. AN0 means analog channel 0. Analog to digital converter channel 0. AN0. RA0. Port A 0th bit. Port A 0th bit. So as you have seen in the previous table, let me go to previous table. There are 6 pins in port A. So out of shared between ADC and port A. So this port A and ADC functions are multiplexed. That is why in the next diagram, RA0 is the 0th bit of port A. AN0 is the analog to digital converter channel 0. So two functions in the same pin. And this pin is a bidirectional pin. See the arrow mark, double-headed arrow mark. Look at the double-headed arrow mark. This is a double-headed arrow mark. This shows that this pin is bidirectional. It can accept data inside as well as it can output data outside. It can send data outside and receive data inside. So this bidirectional pin. Whereas in master clear pin is unidirectional. The signal can go only inside. It cannot come outside. Similarly, pin 3 RA1. That means first bit of port A. Here you see second bit of port A. Here you are looking at the third bit of port A. RA4, fourth bit of port A. RA5, fifth bit of port A. So the number runs from RA0 to RA5. Totally 6 pins. Totally 6 pins for port A. RA0 to RA0, RA1, RA2, RA3, RA4, RA5. Totally there are 6 pins allotted for port A. And these pins are also used for ADC. See, AN0, AN1, analog to digital channel 1, analog to digital channel 2, analog to digital channel 3, and RA4 is used for timer, inbuilt timer. It is used for inbuilt timer clock output. RF5 is used for analog to digital channel 4. Analog to digital channel 4. These are the pin functionalities. And this one, AN2, in the adjacent is written V reference, C reference voltage. So for functioning of the analog to digital converter, we need a reference voltage. We need a constant reference voltage. This constant reference voltage is supplied in that pin when this port is acting as a analog to digital port. So these 6 pins will either act as a analog to digital converter pins, or it will act as a port A bits. So these 2 functions are intelligently multiplexed. Next, look at the port B pins. Look at the port B. If you go to the right hand side of the chip, it's the left hand side. This one is the right hand side. So you see 33rd pin, 33rd pin, 34th pin, 33rd pin, RB0 starts here. RB0 means 0th bit of port B, 0th bit of port B, first bit of port B, second bit of port B, third bit of port B, likewise 4th, 5th, 6th, 7th. So there are 8 port B bits. There are 8 lines of port B here from 33rd pin to 40. So there are 8 pins. That is why it is written here. Port B consists of 8 pins. Port B consists of 8 pins. These 8 pins are used for port B as well as external interrupt handling. So coming to the pinout diagram, here you see the RB0 is also used for giving external interrupt. INT, external interrupt you can give here. So this pin alone is multiplexed. So RB1, RB2, RB3, RB4, these are the other port bits. 8 bits of port B. Now look at the port C bits. How many port C bits are there in the previous table? 8. Once again 8. 8 pins are allotted for port B in the 40 pin package. These 8 pins are used as port C as well as for timer functions and serial input functions. Now we will see. Find out the RC0. Where is RC0 in the diagram? Here you see RC0, port C, 0th bit. RC1, port C, first bit. RC2, port C, second bit, third bit. RC3, here RC4, 4th bit of port C. RC5, 5th bit. RC6, 6th bit. RC7, 7th bit, totally 8 bits. RC0 to RC7. This forms the port C. This port C is shared for other purposes also. So the 15th bit, 15th pin. 15th pin is bidirectional pin. If you notice a double-headed arrow here, that means the pin is bidirectional. If you see a single-headed arrow here, this means the pin is unidirectional. It's coming outside, but this pin is going inside. It's the input pin, it's the output pin. But this one is a bidirectional pin. It accepts as well as sends data. Okay. RC0 is shared in timer 1. RC1 is shared in CCP2 capture control function. RC2, RC3, RC4, RC4 SDA, SDA, RC5 SDO, RC6 transmit clock bit. These are used for serial I/O functions. TX, CK, RX, DT. These are all used for serial I/O functions. Serial I/O functions. So that is why it is written here. So 8 bits. 8 bits. Port C consists of 8 bits. Port C consists of 8 bits. It is shared between parallel port as well as serial I/O and timer I/O. Okay. Then port D. Coming to port D. What is port D? Port D consists of 8 pins. It is shared among the parallel slave port. Notice the port D here. Look at the port D, 0th bit. RD0. Here you see RD0. RD0, it is shared with parallel slave port 0. RD1, port D bit 1, parallel slave port 1. RD0, RD1, RD2, RD3, RD3, RD4, RD5, RD6, RD7. So this forms RD0 to RD7 forms 8 bits. Similarly, PSP0 to PSP7. This is the parallel slave port 7. What is parallel slave port? You must know. What is parallel slave port? Here is the answer. What is PSP? Parallel slave port. Parallel slave port is an interface found on some PIC microcontrollers. It allows 8-bit asynchronous bidirectional data transfer between the PIC microcontroller and the external devices, such as other microcontrollers or personal computers, PCs. So you can make a connection between the PIC microcontroller and other microcontrollers or external devices or personal computers called PCs. So this connection is possible with the help of the parallel slave port. This is a special option available in PIC. Parallel slave port option. This is available in PIC microcontroller. This is available in port D bits. This is available in port D bits. PSP0 to PSP7. It is attached with RD0 to RD7. It is multiplexed with RD0 to RD7. Okay. Next, port DE bits. Port E bits. How many bits are in port E? Only 3. There will be 3 lines for port E. Multiplexed with ADC in 7X series. Now we will see in the pinout diagram. Here you see RE0, RE0, port E 0th bit, port E first bit, RE1, port E second bit, RE2. These 3 lines forms a port E. And it is also shared with this red marked pins. AN5, AN6, AN7, analog to digital converter 5, analog to digital converter 6, analog to digital converter 7. So there are 8 analog to digital converter pins. You see the red marked pins. AN0, AN1, 3, AN4, 5, 6, 7. So totally 8 channel ADC is available 8 channel ADC is available here. 8 is similar to ADC 0809 chip. ADC 0809 IC chip consists of 8 channel ADC. That all functionality is available here also. Okay. Now we will see some few more details of I/O ports. PIC 16F877 series has 5 input-output ports. They are used for input-output interfacing with the other devices. So it is a very essential component of a PIC microcontroller, provision of parallel I/O ports. So these parallel I/O ports are essential for connecting microcontroller with other devices. Most of these port pins are multiplexed for handling alternate function. That we have already seen in the table as well as in the pin diagram. So the kind of multiplexing is used to handle alternate function for peripheral features on the devices. All ports in PIC chip are bidirectional. Look at the again pinout diagram. You will see all port pins are bidirectional. Port A bits are bidirectional. Port B bits are also bidirectional. Port C bits are bidirectional. Port D bits are bidirectional. Port E bits are also bidirectional. All ports in PIC chip are bidirectional. So it accepts as well as transmit. When the peripheral action is enabled in a pin, it may not be used as its general input-output function. Suppose if we are using it for peripheral action. Suppose we are using an analog to digital converter channel. That means port A may not be available. Only one functionality is available. Either you can use it use the 6 pins as ADC, or you can use it as port A bits. Simultaneously, you cannot use it for both functions. So when the peripheral action is enabled in a pin, it may not be used as a general purpose input-output functions. So this slide shows you port A and TRIS A registers. What is TRIS A? TRIS means TRIS. TRIS means tri-state registers. So there are tri-state registers for each port. So there are 5 ports in PIC microcontroller. For 5 ports, tri-state registers are provided. The tri-state registers are shortly called as TRIS registers. So for port A, this is called a TRIS A register or TRISA register. What is TRISA register? TRISA register is a control register for port A. So it decides, this TRISA register decides whether the line is going to act as an input line or output line. So the decision is done by TRISA register. As you see here, port A is a 6-bit wide bidirectional port. The direction of this port is controlled by TRIS or TRISA. TRISA is a data direction register, DDR, data direction register. So this data direction register decides if setting a bit 1 in TRISA register makes corresponding port A pin as input. Clearing the TRISA register makes the corresponding port A pin as output. So if you clear the TRISA register bit 0, then port A0, that means RA0, that is a port 0 of port A will act as output. So clearing the TRISA register, that is bit 0 of the TRISA register, it will make the port A0 pin, A0 means RA0 pin as output. Suppose if you want to set the port A, RA0 as input, then you must give 1 in the tracer register. So tracer 1 கொடுத்தோம்னா என்ன ஆகும், port A pin input ஆக்ட் பண்ணும். tracer வந்து 0 கொடுத்தோம்னா port A bit வந்து output ஆக்ட் பண்ணும். இதான் லாஜிக். Very simple logic. So this is similar to control register of A255. You might have seen A255 IC, programmable peripheral IC, programmable peripheral chip. So in that IC also there is a register called control register. Control register controls the functionality of the ports. Similarly, in the place of control register, here the terminology is different. Tracer, tris A, or we can read as a tris A or tracer. Next slide you will become more clear. So this is a port A for 6 bits. This is port A 6 bits. Port B 6 bits. In port A, this is a tracer register. For each port line, one tracer register is provided. RA0, RA1, RA2, RA3, RA0, RA1, RA2, RA3, RA4. If you put 1 in the tracer register, the corresponding bit becomes input pin. Look at the direction of the arrow. The corresponding bit will act as an input pin. If you give 0 at the tracer bit, the corresponding pins will act as output bit. Look at the direction of the arrow. It's going outside. It's going outside the chip. Whereas the blue color arrows are coming inside. So putting 1 here, line will be configured as the input line. Putting 0 here, that line, corresponding line will be configured as output port. This is the logic. So this is the correspondence of a tracer register along with the port A bits. Similarly, in port B also there is a register called a trace B, tri-state B register. That is called a tris B register. You can pronounce like this, tris B register. These tris B registers controls the port line configuration. If you put 1 here, that corresponding line will act as input. If you put 0 here, that corresponding line will act as a output. See all these 3 lines, there are 3 zeros. Last line RB0 input, here it is 1. So if you put 1 here, lines will be acting as input line. If you put 0 in the tris register, corresponding line will be act as output. Same idea is extended for port C, port D, port E also. Similarly, there is a tris C register and tris C register for port C. Similarly, there is a tris D register for port D. Similarly, tris E register for port E. Okay. Port A discussion. Now we will continue the discussion on port A pins. Pin RA4 is multiplexed with the timer 0 model clock input to become the RA0 T0 clock 1 pin and function either as input output operation or that is already I told you. So see once again the pin diagram. Pin diagram is very important. RA4 is coupled, is multiplexed with the timer 0 clock 1 C1 out. That explanation is given here. Pin RA4 is multiplexed with the timer 0 module clock input to become RA4 dash pin and functioning either as input output. And this pin is a Schmitt trigger input and an open drain output. And this pin is a Schmitt trigger input, open drain output. All other port A pins have TTL input levels and full CMOS output drivers. What does it mean? What this statement means? is a Schmitt trigger input. Schmitt trigger. What is Schmitt trigger? Schmitt trigger is a comparator circuit with hysteresis implemented by applying positive feedback to the non-inverting input of the comparator or differential amplifier. It is an active circuit which converts analog signal, input signal into a digital output signal. That means if you give any input to the Schmitt trigger input, RF4 acting as a Schmitt trigger input, if you give any kind of signal, then it will be converted into square wave. So analog signal will be converted into digital signal. That means any variations appear in the zigzag fashion in RF4 pin, that will be converted into digital signal by the Schmitt trigger action. The next one, CMOS output drivers, TTL input levels. What does it mean? Here I am having the answer. CMOS logic level. So the chip is adaptable with the TTL devices as well as the CMOS devices. The peripheral devices can be either TTL or CMOS. So both interfacing is possible. So CMOS gate circuits have input output. So what is the range of CMOS? 0 to 1.5 is classified as a low logic level. 3.5 volts to 5 volts is classified as a high logic state. So in CMOS configuration, complementary metal oxide semiconductor logic, this is a voltage range. 3.5 volts to 5 volts is taken as a high. 0 to 1.5 volts is taken as a low. What is TTL logic level? Everything is given here. 0 to 0.8 is considered as a low for the input signal levels. 2 volt to 5 volt voltages are considered as a high level in input side. Whereas in output side, this is the input, this is output. So in output side, 0 to 0.4 are considered as a low level logic. 2.7 to 5 volt are taken as a high level logic. This is so IC, the PIC microcontroller IC supports both the TTL interfacing as well as the CMOS interfacing. That is a concept. Okay. Goodbye to all.